Once the installation of our ROS2 is completed, we need to move toward the next step. And that step is creating our own workspace and a package inside of it. Let's take a look how we are going to do that. We are going to be using a terminal for sure for everything. I have opened up the wiki pages for these processes. All of the tiny details are provided inside of these wiki pages. That's why I am showing you. What? What? The name of the workspace is going to be Robotic Arms Workspace. And that's it. mkdir make a directory -p, meaning create a subdirectory inside of it, and the name of the directory is going to be Robotic Arm Workspace Bazoo or Robotic Arm Workspace. That's it. The subdirectory we are going to be creating is source folder is the folder that is going to contain all of the packages. Here I have Robotic Arm Workspace and a source folder inside of it. I need to source ROS2 so I can access the Colcan build. I'm going to go inside of this workspace and then the source folder and perform Colcan build. What Colcan build is going to do is create multiple folders along with the source folder. Let me show you Colcan build, and it is going to compile this workspace and form it into sort of a, I think I made a mistake here. I should have not gone into the source folder. So let's get back to this folder, which is here. I'm going to delete all of these things because we need to build it in the workspace. Again, perform Colcan build, and it is going to create build, log, install folders. In source folder, there should only be packages. Now I am going to create the package that we will be using throughout the course, and let's go to this creating your ROS2 first package. I am going to be using Python. It is telling me what the structure is going to be. This is the basic command to create a package. Okay, we are in the source folder. Here we need to get to the source folder. Now we are in the source folder. I'm going to paste the command. It is going to give error because package name is not given. Package name is going to be Big Bazoo. That's what I came up with. The first package we are going to be dealing with is Big Bazoo, and the syntax is simple. ROS2 package create build type emit Python. Pressing enter, and you can see a package has been created. I am now going to perform Colcan build outside of this source folder, and let's see, it has automatically compiled. What next thing I need to do is to provide a path to our workspace. Inside of our workspace we have this install folder and this setup.sh file. This file needs to be accessed by the system to access this whole workspace, all of the packages inside of this source folder. Now to do that we need to do obviously the same process we did for the ROS2, but let me show you why do we need it, right? If I perform ROS2 run and the name of the package that we created, which is Big Bazoo, and I'm pressing tab, it is not automatically completed because it does not know where this Big Bazoo package is placed. And if I source it inside of the install folder and setup bash, I have sourced it manually. Now if I perform ROS2 run and BIG, pressing tab, it automatically completes. Now it knows where this Big Bazoo package is, although there is nothing inside of it, but sourcing is essential here. So I am going to go in my VS Code and I press Ctrl O to open up, go to home folder, pressing Ctrl H to show me hidden files as well. Here we have this bash rc file. I'm going to open it inside of my VS Code in a restricted mode. There are a lot of things and they are very sensitive things. You have to be very careful. Coming to the last portion, I have this ROS folders source in I have this ROS sourcing command line here pasted. We don't need to do that again. This is a sourcing of my another workspace. But what I want robotic arm workspace to be source. So what is going to be the path? Let me create the path. Source from the home folder, robotic arm, then install and set up bash. So we need to copy whole of this and paste it here. This is my ROS1 installation source. Currently it is not source. I have commented it out because I am using ROS Foxy ROS2, and this is the workspace that I want to continuously source it. So it has been done. Let me now close the terminal that I had, save it, and close this VS Code as well. Open up the terminal again to check if this workspace has been sourced or not. ROS2 run BI in pressing tab, it automatically completes without me doing manually sourcing. So basically sourcing has been done. That's awesome. We need to now open up in our VS Code to make our life a lot easy. Open folder, home, and where was it? Robotic arm workspace, source, big bazoo, add. I'm going to add this package into my VS Code, so things get very easy. File managing gets easy, creating and editing files gets a lot easier. So that is how it is going to be. One last thing before getting started is the extensions we are going to be using. The first one is ROS. This one is very essential by Microsoft because we are going to use it a lot in our simulations, in writing the code snippets, and in developing of the robot as well. So this ROS one, then the second one is ROS snippet. It is again very essential, very useful when we are typing the code. So ROS snippet, simple ROS, then code runner. Code runner is required to run Python nodes. It is not very essential as compared to other ROS one, but still we are going to be needing it. Now the next one is XML. This basic XML and XML tools, the first two, they are very essential for writing the code in XML, that is URDF, and the setting files of RViz as well are in XML. So we are installing these extensions once and for all. We will explore their use cases when we are working with the files. The last one, icons. I like this one extension because VS Code icons, it creates a lot of difference when developing. You can see the folders are created inside of it and given proper icons to them, and this gives a visual easiness when working using VS Code. So that's it for now. All the things are set. Now we need to create nodes and understand how things work. So let's get started.